So this video is going to take you through the types of questions that are going to be on your September exam for higher this year. So we'll have some multiple choice questions, and then we'll obviously have main body paper questions. The video will be quite long, but hopefully I'll work out how to chapter it so that you can go to particular questions on particular topics. I have taken these questions from previous SQA examples. The only exception is the chromatography questions, and I have not done these questions myself, so this is me going through them for the first time as well, so you will see where I make mistakes and I'll talk through my thought process for all of these questions. Okay, I've got a data booklet, I've got a calculator, and I'm just going to get started. So, my first question, I've got an equation, it's a balanced equation. Got copper oxide, ammonia reacting to form copper, nitrogen and water. I've got no state symbols, so that in my head triggers look for temperature, because I've got water, I need to look at temperature, I need to know what state these are going to be in. Now it says, what volume of gas in centimetres cubed would be obtained by the reaction between 100 centimetres cubed of ammonia gas and excess copper? So that's in excess, which means all of this is going to react. So that means we don't need to worry about any ammonia being left over at the end. So we just need to think about the products. So what volume of gas would be obtained? And we're told that there's 100 of ammonia and excess copper. All volumes are measured at atmospheric pressure and 20 degrees C. So at 20 degrees C, copper is a metal, it's going to be solid. Nitrogen is pretty much always a gas, so that's going to be a gas. And water at 20 degrees, that's going to be a liquid, so we don't need to worry about that. So all we need to look at is 2NH3 going to N2. So it's a 2:1 ratio. We were told we had 100 of this. So 2:1, we divide by 2 there, so we're just going to divide by 2. Give us 50, and so that matches one of our answers. 50 it is. Okay, next question. Particles with the same electron arrangement are said to be isoelectronic. Which of the following compounds contains ions which are isoelectronic? So that means that basically they both, once they've formed ions, have the same electron arrangement as the same noble gas. And the way that this works is because metals lose electrons, they're going to have to be on the period above the non-metal which gains electrons. So using your data booklet, you would look up page 7, page 8 and look at your electron arrangements and go through each one. What is its electron arrangement, and what would its electron arrangement be as an ion? So for calcium, I'm here. So when I look at my data booklet, calcium is 288 as an ion, because it was 2882. Chlorine is going to be, it's 287, so that's 2882, which goes to 288. Chlorine is 287, and so when it forms an ion, it's going to be 288. So actually, we've already answered it. Potassium, its ion is going to be 288. Bromine is going to have much more than that. Magnesium is going to just be 28. Chlorine is going to be 288. And sodium is going to, again, that's going to be 28, and sulfur is going to be 288. So this is our confirmed answer. Right, question 3 here. For elements in group 7 of the periodic table, which of the following statements is true as the group is descended? So this is a trends in the periodic table question. Now, as we go down the group, boiling points. So boiling points, we can, if you want to, you do have boiling points, melting points on page 6 of your data booklet. And here we see, if you can see, for the halogens, the boiling points are increasing. They're getting less negative and then they're becoming positive. So that one is incorrect. Covalent radius decreases. Well, as we go down a group, the number of shells increases. So the covalent radius should also increase. So that one is not true. First, ionization energy increases. Well, also, ionization energy, when you have more shells, which is what we were going to get as you go down a group, with more shells, the outer electrons are shielded from the force of attraction from the protons in the nucleus, and so ionization energy decreases down a group. So that one's incorrect. The strength of the van der Waals forces increases. Well, in halogens, they're all diatomic, and so the van der Waals forces, the only van der Waals forces that they can have if they're diatomic elements, is your London dispersion forces. London dispersion forces get stronger when molecules are bigger or have more electrons. As you go down the group of halogens, you're going to have more electrons, and so definitely the strength of London dispersion forces is going to increase, and so D would be correct. Question 4. Atoms of nitrogen and element X form a bond in which the electrons are shared equally. Element X could be which of those? Well, what we'd be looking for is we're sharing equally, so we're thinking about polarity. And if they're sharing them equally, that means there's going to be no difference in polarity, so no difference in electronegativity. And so we're going to turn to our page on electronegativity. We're going to look at nitrogen. Nitrogen has an electronegativity of 3, and we just want to see what other element has an electronegativity of 3. We've got one here. When I go across, that's chlorine. Is that one of our options? Yes. So there we go. If you want to, you can check all the other ones. So carbon is 2.5, so it's not the same as 3. Oxygen is 3.5, so again, that's not the same as 3. And phosphorus is 2.2, so that's also not going to work. So that's definitely chlorine is our only possible answer there. Right, so now we've got 2 questions, and these are both calculation related. So first one, we've got hydrochloric acid reacts with magnesium according to the following equation. Magnesium plus 2H plus goes to magnesium 2 plus H2. The first thing we need to get sorted out is what is the chemical formula of hydrochloric acid. Hydrochloric acid is HCl. You're expected to know that, and when it dissolves, it forms H plus and Cl minus. So this 2H plus corresponds to 2HCl. So that's just adding one step. So we've got a ratio of magnesium to HCl is 1 to 2. Now we can read the rest of the question. What is the least volume of 4 mole hydrochloric acid? So that's a concentration. So we've got, and we want to know what the volume is. That can completely react with 0.1 moles of magnesium. So that's 0.1 moles. We don't need to do anything. We don't need to look up GFM because we're told the moles. So if we've got 0.1 moles of that and it's a 1 to 2 ratio, that means we have 0.2 moles of hydrochloric acid. And so N equals that, C equals that. What does V equal? Now we know N equals CV. So V is equal N divided by C, which is going to be 0.2 divided by 4. And I've got a calculator somewhere. 0.2 divided by 4 is 0.05 litres. Now all of these are centimetres cubed, so to turn litres into centimetres cubed, we multiply by 1000, which is 50. So that is our answer, it's going to be 50. So the key is, what is the molar ratio? We're given the number of moles of magnesium, so we can work out the number of moles of hydrochloric acid. And we've also been given a concentration. So it's a National 5 calculation, N equals CV, so V equals N divided by C. The next one is an excess question. Now we've been told, we've got our equation, it's balanced, and we've been given the gram formula mass of two of our reactants here, of our reactant and of our product. We are told 2 grams of calcium carbonate reacts with 200 centimetres cubed of 0.1 mole per litre nitric acid. So we're given all the information necessary to work out the moles of both of our reactants. So that's what I'm going to do first. So I'm going to start Ca, I'll write in black, sorry, CaCO3 and the ratio to HNO3. Now, I'm not putting the 2 in front because I'll use the molar ratio later on. That's my chemical, that's my chemical. GFM here is 100 grams and I've got a mass of 2 grams. So N is M divided by GFM, which is 2 divided by 100, which is 0.02. Sorry, 0.02. With our nitric acid, we were told 200 centimetres cubed, so volume equals 200 centimetres cubed, which is equal to 0.2 litres. And the concentration was 0.1. N equals CV, which is 0.2 multiplied by 0.1, which equals 0.02. That's what I have. That's what I have. Now my mole ratio is 1 to 2. Now that's from here, that's 1, 2. So I'm going to take one of these, my calcium carbonate. If I have 0.02, I am going to need 0.04 moles of nitric acid. And I need more than I have, which means this one is limiting, and that one is excess. So at this point, let's see, can we rule out anything? So calcium carbonate is the limiting reactant. We know that one is not true, it's in excess. Next one says an excess of nitric acid remains at the end of the reaction. Well, it's our limiting reagent. So that is also not true. Now we need to think about the other ones. And we need to think about our products. We always use our limiting reagent to predict our products. So HNO3 to CaNO3 2 and CO2. The ratio is 2 to 1 to 1. That's what I have of my HNO3. So I have 0.02, and that means I'm going to produce 0.01 moles of that and 0.01 moles of that. Now I just need to see which one of those is true. The gram formula mass of calcium nitrate is 164. And what would mass be? M equals N times GFM, which is 0.01 multiplied by 164, which gives me 1.64 grams. That's what C tells me. 1.64 grams of calcium nitrate is produced. Let's just double check the last one. 480 centimeters cubed of carbon dioxide is produced by the reaction. Well, that's my number of moles. And molar volume is here, 24 litres for 1 mole. So that, when we multiply it to give us volume equals N times mole vol, which is going to be 0.24 litres, which is 240 centimetres cubed. So that one is wrong. And so definitely C is our confirmed answer. Moving on to our final two multiple choice questions. An element contains covalent bonding and London dispersion forces. The element could be. So we've got to think and do a process of elimination. It contains covalent bonding. So are there any elements that we can eliminate? Well, boron has covalent bonding because it's a covalent network. Neon, monoatomic. So it doesn't have covalent bonding. Sodium is a metal, so it has metallic bonding, so we can rule it out. And sulfur is a covalent molecule. So that is network, and that is a molecule. So in terms of covalent bonding, that one does, that one does, that one does, and that one doesn't. In terms of London dispersion forces, if something is a network, it does not have intermolecular forces. So that doesn't meet it. These two we already know it can't be. Sulfur is S8, and those molecules always have London dispersion forces, so that is our answer. For our final question here, which of these has polar molecules? Now, a polar molecule, what you need is either, firstly, you need a difference in electronegativity. So you need a difference in electronegativity. And it needs to be asymmetrical. So all we need to do for all of these, all the bonds are identical in each molecule, so they're all the same. So a difference in electronegativity is going to be present in every single one. So all we're going to check is it symmetrical or not? Well, that is tetrahedral. That is symmetrical. CO2, if we remember, CO2 is linear. That is symmetrical. NH3 is trigonal pyramidal. That is not symmetrical. And finally, we've got the CCl, which is going to be a tetrahedron again. And that is symmetrical. So the only one that's not symmetrical is ammonia, so it has to be our answer. What I'm going to do is I'm going to actually start a new video, so there'll be a part 2 where we go through the other questions.